make sure that you remember this. So Thursday, May 8th at 10 a.m. And then Friday, May 2nd, that's going to be in class, of course, at 10 a.m., a regular class. And then Wednesday, it's not May, it's going to be April 30th at 10 a.m. This is going to be the first part of our final, second part, and third part. So today is Wednesday, April 23rd, right? So Wednesday, April 23rd, we're going to review for part 1. Friday, April 25th, we'll review for part 2. And then Monday, whenever that is, 28th, we'll review for part 3. So that's why we only have enough time to just start right now. We only have 3 more days to review and then 3 days to actually do it. So let's go ahead and get started. So let me erase that and get started. So the final review, I think I have actually posted it into Moodle, and it's like as real world as it can possibly be. This is actually from a previous fall. So I just basically took the file and changed the title of it and used some actual problems from a previous semester. These are all questions that were from a final before. The problems are going to be very much the same, but the committee that develops the final changes the numbers slightly each time. And sometimes they also throw in a few new problems, but usually it's pretty much the same concepts. So it's basically the same problems. So number 1, make sure you take notes on this. And by the way, on the final, I think I'm the only teacher who ever allows this. And the only way I got away with it was by using it as a way of encouraging you to study. But when you come to the final, you can bring one regular 8.5 by 11 size blank piece of paper with you. And it cannot have anything printed on it, but you can handwrite as much as you want to. This is to encourage you to study. So it can't be like a cheat sheet that's printed, like you can't bring the review with you, but you can write everything on the review by hand and then bring that with you. So you can bring 1 page of paper with handwritten notes. Nothing can be printed, but just handwritten notes. And you can use 1 page for the first part, 1 page for the second part, and 1 page for the third part. So they can be different pages for each part. So when you have 2 fractions on each side of the equation, the quickest way to solve that is to cross multiply. So just take the bottom of the right times the top of the left and take the bottom of the left times the top of the right. This only works if you have just 1 fraction, 1 on each side, 1 on the left, 1 on the right. So then you get x times x plus 4 equals, now when you put the top, since that's a group of more than one thing, you have to put that one in parentheses now. So it's the top of the right times the bottom of the left. Then you distribute the parentheses. So x times x is x squared. X times 4 is 4x equals, and then x times 2 is 2x. X times x is x squared. 6 times 2 is 12. And 6 times x is 6x. Like that. Perfect. Then we're going to try to move the x squared to the same side. So I'm going to subtract x squared from both sides. Then what I'll have left is 4x equals 2x plus 12 plus 6x. Now I'm going to combine the like terms on the right. 2x plus 6x equals 8x. So you have 4x equals 8x plus 12. Then I'll subtract 8x from both sides. Whoops, where did I get 12 from? Okay, my brain sometimes focuses on the wrong number. Minus 8x. Then you have negative 4x equals 12. Then you're going to divide by negative 4. So you're going to get x equals negative 3, like that. So now, this is actually where I always forget the important part. But at the beginning, whenever you have x's in the denominator, you have to remember any x in the denominator cannot be certain values. So go up to the top and write down x cannot equal two different numbers. What is x not allowed to equal ever? Let me get this pointer so you can see it more clearly. X cannot be -2 because if x is -2, 2 plus -2 is 0, and you're not allowed to divide by 0. So x is not allowed to be -2. And then look at the other fraction. X cannot be -4 because -4 plus +4 would equal 0, and you're not allowed to divide by 0. So keep that in mind, though, because there's about a 1/3 chance that the question on the final will not have a solution. So do you see how that the solution that we got was actually exactly, we got lucky, we got exactly right between those two numbers that did not work. Because -2 did not work, -4 did not work, and we got -3. If the answer comes out to be -3 and it does work, then that's correct and you'll get credit for it. But there's a small chance that it won't work because it might randomly happen to hit one of those two values that does not work. And I think I'm only allowed to give you like half credit for it at most if you get one of the answers that doesn't work and you say that it does work. So it's kind of not fair because sometimes people are just as smart and sometimes they get lucky and get full credit for it. And then sometimes they're still just as smart, but they only get like half credit for it. So make sure you remember anytime you have an x in the bottom of a fraction, remember what it cannot equal. And if it equals something different, then that's a valid answer. But if it equals what it cannot equal, then you have to say that there's no solution to that. So there's question 1. Let's go ahead to question 2. And by the way, remember I said that I would have like strategies for doing the final as well. In question 2, there's a strategy to it. So question 2 says 3x minus 5 squared equals 32. So there's a long way and a much shorter way to doing this. The long way is to go ahead and start expanding out the square, like doing 3x minus 5 times 3x minus 5, and like working all of that out. One thing that the final does is try to separate like the really good students who deserve like top scholarships from the ones who maybe should just like not get scholarships. Actually, I don't think they actually look at it to give scholarships though, but maybe somebody does though, because we have to keep them on record and things. But anyway, all you have to do to actually solve this is just take the square root of both sides. So then the square root cancels out the square, and then you don't have to expand out that power of 2 at all. But you do have to remember though, anytime you take the square root of a square, remember way back in intermediate algebra, the square root property. Anytime you take the square root of a squared, the value on the other side has to have something extra in front of it. It's not correct to just simply say the square root of the other side. What do you have to put in front of the other side after canceling out the square on the left? You have to put a positive and a negative, right? So the square root property says after square rooting a square, the other side has to have a positive and negative added to it. Then we're going to move over the 5. So we're going to get 3x equals positive 5 plus or minus square root of 32. Then we're going to divide both sides by 3. Make sure you divide the whole side by 3, not just one part of the side. So then you get this 3 cancels and you get x equals 5 plus or minus square root of 32 over 3. Now, sometimes if you get this answer, I would probably try to give you like 75 or even like 85 or 95% of the credit for it. But I'm not allowed to give you full credit for it though, because, and if other teachers are probably not actually giving you full credit for it, they might take off 25%. Or well, that's not really fair for them to stack up that much, but there is one thing wrong with this answer. Who knows what's wrong with this answer? The square root of 32 is definitely breakable downable. Is that a word? So because 32 has some numbers in it that you can do the square root of. So let's work on that. So go off to the side. Remember that 32 is equal to 16 times 2, right? So therefore, the square root of 32 is equal to the square root of 16 times the square root of 2. And who knows what the square root of 16 is? 4. So really, you should know that the square root of 32 is equal to 4 square root of 2. So the final answer needs to be 5 plus or minus 4 square root of 2 divided by 3. That's the final answer. Perfect. Now let's go ahead to question 4. Wait, not question 4, question 3, my fault. Yes. Do you have a question? Can I wait?
Yeah.
Yeah. Are you done? Perfect. All right. So then question 3, it says 15x to the 2 minus 8 equals negative 14x. Like that. So they're trying to catch you because a lot of people use the quadratic formula to solve this question, and they think A is 15 and they think B is negative 8 and they think C is negative 14. What's wrong with that? Well, there's two things wrong with it. First of all, you cannot use the quadratic formula unless you have 0 on one side. So we need to move the negative 14x to the middle of the left side where it becomes positive 14x so that we have 0 on the right side. And of course, the other thing that was wrong with it is that B is not negative 8. B is the number that has no x. I mean, sorry, B is the number that is beside the x. C is the negative 8. So actually, this is A equals 15, and B equals 14, and C equals negative 8. But the truth is, though, the quadratic formula should only be used if you cannot factor. Factoring is easier if you can factor. So let's try factoring, actually, because factoring is an easier way. So try factoring instead. It should go quicker. So to factor, just drop the square off the x squared, and you keep the 15x in both parentheses. And then you keep this sign. So it's pretty simple as long as you know how to do it. So plus times minus, what's a positive times a negative? It's a negative, right? So put the next sign would be a negative. Now inside of this box and inside of this box, just like Jack and the Beanstalk had some like magic beans, we need to find some magic numbers to put in those boxes, right? Those magic numbers come from drawing a line from the first number, 15, times the last number, 8. Ignore the negative because we've already put the correct signs down. So what's 15 times 8? Let's see, it'd be 120, right? Now, what factors of 120 add up to equal 14? Because whatever factors you get have to add up to the middle number. This is going to be a tough one. I don't actually know yet. So this is such a fresh thing that I've didn't have the solution written down ahead of time. So what about, well, it's obviously not 1 times 120, right? How about 2 times 60? Obviously not that. How about 3 times 40? Not that. 4 times 30? Not that. 5 times 24? Not that. Is it hopeless? How about 6 times 20? It is 6 times 20. So if I put the 20 here and the 6 there, that's going to be it. And I just made a huge mistake. Does anybody realize what mistake I made? Yeah, I forgot that x. Correct. So don't be like me. You have to be better than me. There we go. So it's going to be, and that was a negative sign, right? So it's going to be a positive 20 in that box and a 6 in the other box because the negative is already in front of the 6. Because this means a positive 20 and plus a negative 6 adds up to positive 14. Now we're not done with it yet though, because remember that that's only half of the factoring process. We have to eliminate any common factors because obviously 15 times 15 does not make 15, right? So these numbers 15 and 15 need to be reduced before it's the correct answer. They need to be reduced by whatever's the common factor of them. So what's the common factor of 15 and 20? 5. What's the common factor of 15 and 6? 3, right? So the correct answer is actually dividing by 5, which is 3x plus 4, and 5x minus 2, like that. So it's been factored. Now, why does factoring help you solve it? Because once you factored it, you just set each factor to 0. Boom. Factoring in is one of the key and most amazing processes of algebra because it's the only way to break down a bigger problem with many different parts into separate, smaller parts. So you get, move the 4 over, you get a -4. Move the -2 over, you get a +2. Divide by 3, you get a -4/3. Divide by 5, you get a 2/5. So the solution is those two solutions. Like that. And by the way, if you see me make any arithmetic mistakes or anything like that, make sure you raise your hand and let me know because I did not actually solve these ahead of time. I know that that's terrible of me, but it's possible that I might make a mistake. So keep your eyes wide open. I want to make sure that I do them all correctly for you. Any questions? Okay, so all the other questions that I do during class, I would like already have the answers figured out ahead of time, but this time I'm a little bit playing fast and loose, which is not the best idea, but so 4 square root of 2x plus 3. Wait, did anybody need me to see that what I had written, or did you get it? You got it, I think. Okay, perfect. So 2x minus 3 minus 4 equals 0. So this question is the opposite though. This one you don't, there's only one x involved. So you don't have to get it all equal to 0. You have to get the x by itself. So we're going to move this over and we're going to get 4 on the other side and then square root of 2x plus 3. Now just that, like the opposite of a squared power is a square root. The opposite of a square root is a square power, or basically a power of 2. So just take a power of 2 to both sides. Boom. Now the square squared cancels out the square root. And now when you square something, you always get a positive. So you do not need any more. You don't need a positive and a negative in front of the other side. You just need a positive only. So don't add a negative and positive in front of the right side like we did on the last one. So in question 2, you have to add a positive and negative to the right side. In question 4, you don't. Now, so, oh wait, look, 316, that means John 3:16. Every time I see that, I try to remember. So 2x equals 13. So 2x equals 13, and now I divide by 2. Divide by 2, x equals 13 halves. Now, I want to also remind you about something about square root equations. Remember that in question 1, we had an x inside of a denominator. And anytime you have an x inside of a denominator, you have to make sure the denominator is not 0. As long as it's not 0, then it's going to work fine. But if it is 0, then it does not work. With square roots, it's a little bit more complicated. A square root is not a denominator. It's more complicated than a denominator. The only way to tell for sure if an x inside of a square root really works is actually by trying it. So in order to get credit for the problem, you need to try the solution to make sure, because there's like a 20% chance that it won't work. So you have to, anytime you solve an x inside of a square root, you have to check the answer. That's the only way to make sure that it really works, because sometimes they just don't work for no reason at all. So check this answer. So plug 13 halves into the original equation to make sure it works. So 2 divided by 2 cancels out. So that 2 cancels that out, and you get 13 plus 3, which is, what's 13 plus 3? 16. Square root of 16 is 4. So 4 minus 4 equals 0. That's true, right? Whoops, actually it should be a green check mark, not a red check mark. My fault. So that is a correct solution. So you know that it works. Now, usually on the final, they don't really have very many times that the square root equation doesn't work, but it does happen once in a while. I think they just got tired of taking off points for it, and they don't usually have it not work very often, but it can. There's always a chance any x inside of a square root will just randomly not work. Okay, so let's do number 5. Any questions about number 4? Okay, good job. You're becoming the best and the brightest right now. Did you know that? So question 5. which stands for I'm glad to be alive. It is absolute value 3x minus 5 plus 2 equals 11. 3x minus 5 plus 2 equals 11. And once again, there's only one x inside of this problem, so we're going to solve it by getting x by itself. So move over the 2, which, well, when you move it over, it's the same as subtracting it. So we're just going to subtract the 2 from both sides. So then you get 3x minus 5 equals 9. Cats have 9 lives. Sweet. Then you can't really divide by anything because an absolute value symbol is not a number. It can't be divided, can't be multiplied, can't be square rooted or anything like that. The only way to get rid of it is to just remember that if you drop the absolute value, then what used to only be positive, because absolutes can only be positives. So if you take off the absolute, it could be a positive or a negative. So simply drop the absolute value and change the other side to positive and negative. Now, some people have the mistaken, it's partly the right idea, but it's not right though. Some people just think that they need to change this to a positive sign because that's inside the absolute value. But that actually doesn't, the absolute value does not change that to be a positive though, because that's subtracted from 3x. What the absolute value does is it does not change the 5 only to be a positive. It changes the value of it to be positive, which is actually the other side. So when you take off the absolute value, it does not change the -5 to a positive. It only changes the 9 to a positive at first. And when you drop it off, then the 9 becomes positive and negative. The -5 does not change at all. Now you move over the -5, and when you move it over, you get a +5. And then you divide both sides by 3. 3 and 3. So x equals 5 plus or minus 9 over 3. I forgot the minus. There we go. 5 plus or minus 9 over 3. Now this, you probably get like 3/4 of the credit for this. But this is still not the final answer. Why is this not the final answer? Because think about it. You can actually go further than that. Because what is 5 plus 9? 14, right? So actually, x really could equal 14/3. Or what's 5 minus 9? -4, I believe. So it also could be -4/3. So the correct solution is 14/3, -4/3. There's 2 different solutions to it. Okay, any questions about that? Now we come to one that's going to be really hard to remember unless you remember a certain chapter that we just did, chapter 7. And even maybe we even did this in another chapter as well. So question 6 says x plus 3 squared plus parentheses y minus 5 squared equals 25. And it says find the center and radius of the circle. So who remembers how to find the center of a circle when you see its equation in standard form? That's the standard form of the equation. How do you find the center of a circle from the standard form of the equation? The center of the circle is always basically it's the shifts that have happened. And when you have a number in parentheses next to a variable, it shifts it in the opposite direction as that number. So x plus 3 actually shifts the x to -3. And y minus 5 shifts the y to a +5. So the center of the circle is -3, 5. And the radius of the circle is the square root of the number on the other side of the standard form, which is 25. So the square root of 25, which is 5. Boom, we did it. Excellent. Now, question number 7. So question number 7. This is a whole, well, let me actually start with the blank page on this, because this is going to be a little bit bigger. So blank page. Question 7. Log base 3 of x plus 4 plus log base 3 x minus 4 parentheses equals 2. So your first step, you have to condense the 2 logarithms into 1. And remember, to do that, we need to know the numbers in front of logarithms, which is +1 and +1. And how do you condense any number? It could be many, it could be 2 or 10 or any number of logarithms. How do you condense a whole bunch of logarithms that are all separate from each other, separate terms? How do you condense them all into one logarithm? What do? How do you make that onto just a single log base 3? Well, what you do is you take every factor within them, you crunch them together, like multiply them together like this, and then you keep on going. If you had more logarithms, you'd multiply all those factors together. And on top of each factor, you put the number that was the number that was in front of each logarithm becomes the power that is on top of each factor. So this basically condenses it all to be inside of a single logarithm. All the factors come multiplied together inside of one logarithm, and all the numbers in front of the logarithms become powers on top of those factors. So we condense it together. Now, who remembers what this 3 is called? What's that 3 down there called? That's the what of the logarithm? That's the base of it. So we have to start with the base and then leave some space, because base rhymes with space. Then write the base on the other side as well. So we take the equation 3 equals 3, and then we exponentiate the other equation on top of that equation. So basically it's 3 to the power of the log base 3 of that stuff, and then 3 to the power of 2. Then we're going to take the base, a base 3, and the function log base 3 and the exponent of it. Those are opposites of each other. So this 3 crosses out the log base 3. Then you're just left with x plus 4 to the power of 1 times x minus 4 to the power of 1. The power of 1 doesn't really matter, so I'm just going to not even write the power of 1. So equals 3 squared, that's equal to 9. Now in this case, we have 2 x's, not just 1. So we cannot get an x by itself by like moving everything to the other side. So instead, we're going to have to multiply it all out together and then set it to 0. So go ahead and multiply this out. You get x squared plus minus 4x plus 4x minus 16 equals 9. Thankfully, the middle terms cross out. Boom. So x squared minus 16 equals 9. Now subtract 9 to get 0. You have to have 0 on the other side. Wait, actually, that's not quite true, because we only have 1x now, actually. But in general, you probably will, most of the time, these things won't cross out. Most of the time, they won't cross out. And then in that case, you'd have to set it to 0. So we're going to go ahead and set it to 0. So we'll get x squared minus 25 equals 0. Right? Now, since there's no x term in the middle of it, if you wanted to, you could actually move this to the other side and then take the square root and then write a plus or minus after taking the square root. But that's not always guaranteed to work. So instead, we're going to factor it, which is going to work. So x squared minus 25 breaks apart into x times x, and negative 5 times positive 5. So we got x minus 5 and x plus 5 equals 0. Then set each of those to 0 by themselves. So x minus 5 by itself equals 0, and x plus 5 by itself equals 0. And then add 5 to both sides. If you do that, I don't have space to show that last step, but if you did add 5 to the other side, you get 5. And then you're going to have to subtract 5 from both sides. If you did that, you get negative 5. Now, once again, when you have x inside of something complicated like a denominator or a square root or a logarithm, you have to follow certain rules for the answers. So these answers are not necessarily guaranteed to be the correct answers, even though we did everything correct in the process we solved them with, they still might not be the correct answers if they don't meet the requirements. So a logarithm can only exist if the inside of it's neither 0 nor negative. So make sure that if you plug 5 in, that you don't get a 0 and you don't get a negative. So what's 5 plus 4? That's 9. That's not 0. That's not a negative. What's 5 minus 4? That's 1, which is not 0. That's not a negative. So 5 passes the test in both logarithms. So this can have a green check mark beside it. And then -5, though. What's -5 plus 4? That's a negative. Negatives are not allowed. Zeros are not allowed either. So since -5 plugged in results in a 0 or a negative, either one of those, it results in a negative specifically, it does not pass the value that this logarithm is allowed to have. So that number is not allowed to exist inside of that logarithm because it would make an illegal number happen. So -5 is not allowed. So that one is not allowed. The only correct solution is +5, like that. And by the way, the reason that it's not allowed is not merely because it's negative, not merely because it's a negative number itself. Like if this had said x plus 8, if that was x plus 8, then -5 would have worked because -5 plus 8 would have been 3, and then it would have been a positive number. But since -5 plus 4 is not a positive number, that's why it does not work. So just because it's negative itself does not mean that it doesn't work. It's only because when you plugged it in that it resulted in a negative or a 0. That's the reason that it does not work. So I have seen ones on the final before sometimes that are negative, and they actually do work because the number in the equation was bigger than the number that you got for the negative. Okay, well, that's number 7. Let's go to number 8, which rhymes with great. So number 8 says -1 less than or equal to -2 x over 3 plus 5 less than 11. So this one looks easy, so you might be tempted to just skip over it and not study it, but that's a sign for, that's a recipe for disaster though. So make sure you practice them even if they're easy. In fact, I'd recommend that you try to do a dress rehearsal for the final. Print out the final from the website in Moodle where I put the final review. Print out the review and then shut yourself into a room with like no technology and no help or anything, and then try to solve those problems by yourself. So the first step is to get rid of the +5 because we need to get x by itself. So not +5, we need to do -5. But this is what some students do. This is not enough though. Why is this not enough to just subtract 5 from both sides? Why is that not enough? Because there's not 2 sides, there's 3 sides in this question. So there's 3 sides. So subtract 5 from all 3 sides. Then you get -6 less than or equal to -2x over 3. And then those knock out each other. 11 minus 5 is 6. Now we have to get rid of the 3 in the bottom. So multiply every side, all 3 sides, because there's 3 sides, by 3. 3, 3, 3. So you get -18 less than or equal to, that one crosses out. So it's -2x less than 18. Divide by -2. Now when you divide by -2, this is where it gets tricky. So I'm going to try to do a whole division by -2 across everything just to illustrate my point. Because when you divide the -18 by -2, you get +9. But when you divide a less than sign, that's kind of like a negative sign, sort of. When you divide a negative by a negative, you get a positive. And when you divide a less than sign by a negative, you get a greater than sign. So that actually changes the sign as well. Do you have a question? What? Yeah.
3, that is in the like multiplying the second one.
Yep.
Where does it come from?
Because I'm multiplying all the, well, it comes from my brain. Because you have a 3 in the bottom, right? How do you get rid of the 3 in the bottom? By multiplying, because the opposite of division is multiplying. But when you multiply one side by a 3, you have to multiply every other side by 3 as well. So I'm multiplying by 3 because I know I have to get rid of the 3 that's in the bottom. Does that make sense? Now I could have made an arithmetic mistake and maybe I'm just missing something obvious, but I think I did everything correctly. But I could be wrong. And then -2 divided by -2 is a positive, so that's a positive x. This sign divided by negative is a greater than sign because it changes the sign. 18 divided by -2 is -9. So that's the final solution. But then it says after solving it, graph the solution on a number line. Now, thankfully, the people in the final are fairly traditional. like old school or whatever. So I don't think they will mind at all if you don't put this in interval notation. So we're going to skip interval notation for right now. That's the solution for us as far as we need. But it did say to graph the solution on a number line. How do I graph that solution on a number line? Well, you have to put the lower number first. So the temptation is to put 9 on this end and put -9 on that end. Would that be right? No, you can't, because even though it can be written backwards, like when you write out a math problem, you can write it in whichever order you want to write it. But when you put it on a number line, you have to have the numbers in the proper order. The -9 is lower than the 9, so it has to go like that. And then x can be, that's on the little end of 9. So x is littler compared to the 9, which is on the big end. So it should go, x should be within this region because it's littler than 9, but x is on the bigger end of -9, so it should be bigger than -9. So it should be shaded to the right of this part and to the left of that part. So we're going to shade, boom. Okay, so we shaded where x is, but then there's one more detail that you have to put in order to get full credit. Can x be equal to +9? Yes, x can be greater than, not x. 9 can be greater than or equal to x, which means that x can be equal to 9. So fill in the 9 with a positive, or not positive, with a solid dot. And then x cannot be equal to -9 because there's no equality underneath that symbol. So there's an open dot, a -9, like that. Now, if you wish, if you love interval notation, which I want to encourage you to love math, if you love it, you can also just write the smallest number first, the biggest number last, and then put a parentheses where the open circle is and put a bracket where the closed circle is. That's interval notation, but it does not say that that's required on the final. So this is not required. This is just optional. What is required is this and this. This one is just optional. So I can't grade you based on whether you have that or not. I have to grade whether you have this solution and whether you have that. Any questions? Okay, well, let's do number 9. So number 9. Number 9 is a system of equations. So it is 3x minus 5y equals 3. 2x plus 3y equals -17. So pay close attention to this because these are kind of difficult on college algebra. These are harder usually systems than the ones you had to solve in intermediate algebra. So 3, -5, 3, 2, 3, and -17. So which is smaller, 3 times 2 or 5 times 3? 3 times 2 is smaller, right? So we're going to work with a smaller set of numbers. Whoops, sorry, that's the wrong color. We're going to work with a smaller set of numbers, the 3x and the 2x. What's a common multiple of 3 and 2? It's 6, right? So it's 6. So we need to get the top one to be 6. How do I get 3 to become 6? Times 2, right? And then I need to get the bottom one to become the opposite. The opposite of 6 is -6. How do I make a 2x become -6x? Multiply this by what? -3, right? So I multiply all the way across the top by 2. I get 6x minus 10y. Don't forget to multiply the other side by 2 as well. So that becomes 6. Now multiply the bottom equation by -3. That becomes -6x. -9y equals 51, like area 51, I think. Is that right? 30 plus 21, yeah. Now add them up. So that plus that knocks that out. This is -19. Y, 6 plus 51 is 57. And then who knows what you get if you divide 57 by -19. I'm actually impressed. It's usually a fraction, but what do you get if you divide 57 by -19? You get -3, I believe. By the way, you can use calculators on the final, but not graphing calculators. So make sure you have a scientific calculator with you. I also bought like 10 scientific calculators, but that's all I have, and there's like 37 of you total. So make sure most of you have your own scientific calculator, because one thing that's definitely not allowed on the final is any kind of cell phone or other technology like that. You cannot use your cell phones at all as calculators. So y equals -3. Now I've got to find x, right? So got to find x. So take this number -3, plug it into the easiest equation of them all, which is the first one, 3x minus 5y equals 3. So erase this letter y right here, erase that letter y, and plug inside of it the value of y, which is -3. Then multiply it. So -5 times -3 is +15. 3x plus 15 equals 3. Subtract 15, like that. 3x equals -12. Divide by 3. X equals -4. So x equals -4, y equals -3, and that's all you have to have. Make sure you have both x and y. So we're going to do number 10. That's a lot easier, thankfully. Number 10. Did everybody get that page, or do you need me to go back to it? Got it? Go back? Okay. Let's see. Okay, perfect. Now, number 10. Okay, so it says in number 10, the time to do a job, it varies. The time to do a job varies, and the word varies means the letter K. So time equals K. And then it says the word inversely. The word inversely means divided. The time to do a job varies, which means K, and then inversely, which means divided, as the number of people, so it's divided by the number of people who work on the job. And then it says it takes 24. It takes 45 hours of time for 8 people to work on the job and finish it. So we have to solve that. So plug in 45 for the time, and we don't know what the K is. We don't know how much variation is happening. So 45 is the time, and P is 8. So cross multiply by the 8 to the left side. So 45 times 8 equals K. So I believe that'd be 360. Let me think. Yeah, I believe that'd be 360 equals K. So now you're going to go back up to the equation and do it over again. So start over again. So say T equals K over P. Now in the second part of the problem, it says, how long does it take for 9 people to do the job? So you're going to plug in 9 for people. But remember, you're also going to plug in 360 for K. Don't forget to plug in 360 for K, because you already found that. The time would be 360 over 9 people. How long would that be? That'd be 40, right? So basically, if it takes 45 hours for 8 people to do it, it's going to be only 40 hours of time if 9 people do it, because they can work on it faster, right? So the final answer is time equals 40 hours. So we have one more question to do for this second page. So I'm going to break, by the way, there's 6 pages of the final from this last final, and I'm going to break it apart into 2 pages on each day. So we're going to do the front and back of the first 2 pages front and back next Wednesday. Then the next 2 pages front and back next Friday. So the last question on the first 2 pages is number 11. So I'm going to clear this drawing. Is that okay? So number 11, this is going to be your favorite one. So ln E 5.73. There's one critical step you have to remember to solve this. Remember that ln is an abbreviation for log base E. So you're going to write down that equals log base E of E to the 5.73. The second step is you need to write a line. The function called log base E is the opposite of the value of base E. So log base E of the base E cancels out. And remember, this number itself comes down to the front. So draw an arrow from that number 5.73 down to the front. Actually, wait, hold on, but let's backtrack. That's kind of confusing to do it all at once. Let me go back, sorry. That would be confusing. First of all, let's move the 5.73 down to the front. So 5.73 goes to the front at first. Then you have log base e of e. Now, cross out the log base e of e. That leaves you technically with 1, actually. So it's equal to 5.73 times 1. What's 5.73 times 1? It's just 5.73. So if you show those steps like that, then you'll get full credit for it. So that was the easiest one of the day. So make sure you come back on Friday to review through the next 2 pages of it. And if I feel generous, I'll go ahead. In fact, I'm going to go ahead and do it anyway, but I'll post a recording of this on to the website. But make sure you're still in class on Friday, though, because if I have bad attendance, I might not necessarily post the next recording. Yes. So the first part of the Bible is only 11 questions? Yes, correct. Yep. First part of it's just 11 questions. And then the next part of it will be whatever, however many questions are on the next 2 pages. Okay. Good question. And by the way, I did not get everybody who walked in late on the attendance page. So as you're leaving, make sure that you come up to me if you walked in a little bit late and get your sign in for attendance.